Hello everyone, welcome back to the online lecture series of subject Power Electronics. This is our second lecture. Now these are the contents of our today's lecture. Now today we will discussing about the power rating of the different semiconductor devices, or we can say the power electronic devices. And you can see in this table we have defining the various semiconductor devices having the various voltage, current and frequency rating. So according to that, the first that will the diode. So in this diagram you can see the symbol of diode. Diode having the two terminals, anode and cathode, and it having the voltage rating of 5000 volt and current rating it is also a 5000 ampere, and the frequency range that is about to 1 kilohertz. Now second one, we are discussing about the Thyristor family member, in which the first member, that is the SCR. The SCR is known as silicon control rectifier. In this diagram you can see the symbol for SCR. So SCR have the three terminals, anode, cathode and gate, and it having the voltage rating in the range of 10 kV and the current rating in the range of 5000 ampere, and it having the operating frequency range in the range of 1 kilohertz. Now second devices, that is the LASCR, that means light activated SCR. In this diagram you can see the symbol for LASCR. It having also three terminals, anode, cathode and gate, and it having the voltage rating in the range of 6000 volt and current rating in the range of 3000 ampere. It having the frequency range in the order of 1 kilohertz. Now our next device, that is the ASCR or RCT, and in this diagram you can see the symbol for the ASCR. It have also three terminals, anode, cathode and gate, but having some different symbol structure. The voltage rating for this device is about 2500 voltage and current rating in the order of 400 ampere, and it having the frequency range in the order of 2 kilohertz. Now our next device, that is the GTO. GTO means gate turn off thyristor, and in this diagram you can see the symbol of GTO. It having also three terminals, anode, cathode and gate, and the voltage rating of GTO is about to 5000 volt and current rating is 3000 ampere, and it having the frequency range of the 2 kilohertz. Now next is SITH, that means static induction thyristor. In this diagram you can see the symbol for SITH, anode, cathode and gate, and the voltage rating for this device is 2500 volt and 500 ampere, and it having the frequency range in the order of 100 kilohertz. Our next power electronic devices, that is the MCT, that means MOS controlled thyristor. So now next in this diagram you can see the symbol for this MCT. It having the three terminals, anode, cathode and gate, and it having the voltage rating in the range of 1200 volt and current rating in the range of 40 ampere, and it also having the frequency range in the order of 20 kilohertz. Now next one, that is the Triad. So Triad, in this diagram you can see the symbol for the Triad. The Triad have some different terminals, but it also having three terminals like MT1, MT2 and gate. Now the voltage rating of Triad is 1200 volt and current rating is 1000 ampere, and it having the 0.50 kilohertz frequency. Now in this table you can see the transistor family member of semiconductor devices, in which first is BJT. BJT means bipolar junction transistor. And now next, in this diagram you can see the symbol for the BJT, it having the three terminals, base, collector and emitter, and it having the voltage rating of in the order of 1400 volt and current rating, that is the 400 ampere, and it having the frequency range in the order of 10 kilohertz. Now our next device, that is the Mosfet. The Mosfet means the metal oxide semiconductor field effect transistor. Now next, in this block diagram you can see that the symbol for the MOSFET have three terminals like gate, drain and source, and it having the voltage rating in the order of 1000 volt and current rating, that is the 50 ampere, and it having the frequency range in the order of 100 kilohertz. Now next one is SIT, that is the static induction transistor. So in this transistor, it having three terminals. You can also see in the block symbol the gate, drain and source, and it having the voltage rating of 1200 volt and 300 ampere, and the frequency range in the order of 100 kilohertz. Now next, our semiconductor devices, that is the IGBT. IGBT means insulated gate bipolar transistor, in it having the three terminals like gate, collector and emitter, as you can see in this symbol, and it having the voltage rating of 1200 volt and current rating is in the order of 500 ampere, and it having the frequency range in the order of 50 kilohertz. So these are all about the rating of the different types of power electronic devices which are used for the different applications with their specifications. Now next, now in this lecture we will study about the power electronics converters, as we also study the basic concept of power electronics converters, what are their types and what are their functions. Now in this lecture we will discuss about the phase control rectifier and different types of power electronics converters. Now our first power electronics converters, that is the phase control rectifier. It is also known as AC to DC converters. So this controller converts fixed AC voltage into variable DC output voltage, and they are also called as line commutated or natural commutated AC to DC converters. Okay, so this is the main function of phase control rectifier. Now next, you can see in this block diagram, this is the block diagram of phase control rectifier, in which you can see it can convert the fixed AC voltage into variable DC output voltage. And we can see the applications of phase control rectifier. The first application of phase control rectifier is in HVDC transmission system. HVDC transmission system means high voltage DC transmission system. So this type of transmission system is used for the long distance, and in this type of transmission system the phase control rectifier is required for converting the power from AC to DC. So this is the main application area of phase control rectifier in HVDC transmission system. Second one is regulated DC power supplies. So control rectifier, it is also used in regulated DC power supplies, where we require the regulated DC power, when we can use the phase control rectifier. Third one is static var compensator. The static var compensator is generally used for the improving the power quality of the overall power system, and in this our compensator, we are using the phase control rectifier for the conversion of power from AC to DC. Now next application of this rectifier is wind generator converters. It is also used in wind power system for converting or for transferring the power from AC to DC. Now next application, that is the battery charger circuit. So these are the some applications of phase control rectifier and their working principle, their mode of operation we will study in the step by step our next lecture. So this is the basic concept of the phase control rectifier. Now next we will study about the second power electronics converters, which is known as chopper, or we can say the DC to DC converters. The main function of chopper is to convert the fixed DC input voltage to a variable DC output voltage, and the DC output voltage may be different in amplitude than the input source voltage. The chopper circuits are designed by using these power semiconductor devices like power Mosfet and Thyristor. And the next you can see the block diagram of chopper. So in this block diagram you can see that in input side there is the fixed DC voltage, and output side we are getting the variable DC output voltage by varying some parameters like duty ratio or duty cycle. So this is the fundamental concept about the chopper. Now we can study about the applications of chopper. So first application of chopper is to used in DC drive. So DC drive, that means it can be used for the speed control of DC motor in various industry applications. So this is the example of chopper. Second example of chopper is it is used in subway cars. And third applications of chopper, it is used in battery driven vehicles. As we also know that it is now these are the trends of the electric vehicles. So chopper are used for the battery driven vehicles. And the next application, that is the electric traction. That means the chopper are used for the locomotive or train for the working of the traction. And the next application of chopper is to switch mode power supply. So that means we can say that in the short form it is known as SMPS. So chopper is also used in our laptop, in our computers. So these are the main applications of choppers, and the detail about the working principle and their mode of operations and their types in the next lecture. Step by step we will discussing the different types of power electronics converters. Now the next power electronics converters, that is known as inverters, and it is also called DC to AC converters. An inverter converts a fixed DC voltage to an AC voltage of variable frequency and of fixed or variable magnitude. The practical inverter has either a battery or a solar power DC voltage source. So that is the main function of inverter. It converts the fixed DC voltage into variable frequency or fixed or variable magnitude. Now this is the block diagram. You can see in this block diagram, here is, you can observe that the input side there is the fixed DC input voltage, and output side we can get the variable voltage and variable frequency AC output. So this is the function of inverters, now we can see the applications of the inverter. So our first application of inverter, it is used in UPS, that means uninterruptible power supply. That means that is used for uninterruptible power supplies, for the example of computer desktop. Second one is aircraft and space power supply. So it is also used for the power supply in aircraft and space shuttle. Third one is for the induction and synchronous motor drives. So that means for the speed controlling of the AC motors like induction motors and synchronous motor drives. And third one, now next one is HVDC transmission system. Again, in HVDC transmission system, the inverters are used for the purpose of converting the power from DC to AC, because in our distribution side we are using the AC power system, but in HVDC transmission system the power is transmitted in the form of DC. So for the utilization purpose we are required the AC power, so we have required the inverter for the conversion of the power from DC to AC. So this is the application area of inverters. And next one is induction heating supplies. So induction heating supplies, that means these are used in various industries like rolling mills for the manufacturing of the various types of irons, rollings. So these are the applications areas of the inverters, and the detail about their working principle, the mode of operations and classification of inverters we will study in next lecture, we'll study in the other lecture. Now the next power electronics converter, that is the cyclo converters. It is also known as AC to AC converters. So cyclo converters are the circuit which convert the input power at one frequency to output power at different frequency through one stage conversion. So this is the main function of cyclo converter. It converts the power at one frequency to output power at different frequency. That means cyclo converters converts the frequency. These are designed using Thyristor and are controlled by the triggering signals derived from a control unit. Now the output frequency is lower than the source frequency. So this is the main phenomena for the cyclo converters. The output frequency in cyclo converter is a simple fraction such as 1 by 3, 1 by 5 and so on of the source frequency. So this is the main significance of cyclo converters. And now these are mainly used for slow speed very high power industrial drives. So cyclo converter is used in the slow speed very high power industrial drives. That means for the controlling of the speed of the AC motor like induction and synchronous motor drives. So these are the main application area of cyclo converter. So these are the basic concept about the cyclo converters. Now this is the all about the power electronics converters, and this is the our last power electronics converter. Now we will study the next topic in the next lecture. So thank you.